9.4, simple graphs starting at the origin, blah, blah, blah. Here we go. Steps 1, start at the origin, decide if the shape of the function is going to be sine or cosine. Our sine wave looks like this. And our cosine wave looks like, okay, something like that. There we go. So we'll decide. Now, these are the positive versions of sine and cosine, and their negatives are going to be the opposite, right? So first, you're going to find your A value. To find your A value, technically, mathematically, what you're doing is just your max minus your min divided by 2, okay? Or just count how far it is from the x-axis, and that's your that. Okay, you have to pay attention to whether it's going to be negative, and that depends on how your graph is starting, okay? Second, you're going to find the period, and your period is P equals your x2 minus your x1. Where does the wave end? Where does the wave begin? 4 is to find your B, which is 2 pi divided by your period. And then 5 is write the equation by plugging everything in. That's it. Here we go. All right, so step 1, looking at the origin, starting at the origin, we have what? What is this? This is cosine. Is it positive or negative? It is a positive cosine. So we're going to be using positive A cosine BX, right? Step 1. Step 2 is to find your A. Your A equals your max minus your min. Or you can just count how far it is from the axis, right? So what is our A going to be? 2. And it's going to be positive because we have a positive cosine. Agreed? Okay. Step 3 is to find your period. Your period equals your x2 minus your x1. Where do I stop? Pi. Where do I start? 0. So what's pi minus 0? Pi. So P equals pi. Still okay? Step 4 is to find your B. Remember, your B equals 2 pi divided by your period. So for this, our B equals 2 pi divided by pi, which is 2. And now I have all of my attributes that I need. So your amp is the absolute value of your A. What's our amp? 2. Our period is our period. What's our period? Pi. And f of x, you're plugging in your A and your B. Are we ready? So we end up with 2 cosine 2x. That's it. That's it. Are you ready to try? Because when I write them back to back, for some reason, it's like a weird thing. I can't write it the same. I'm
Oh.
But if I think about it, I'll do it right. I just have to think about it. No. If it bothers you not to have it, then yes. But no. All right. Okay, your turn. Oh, don't look. Nothing. What? All right. Hello. There we go. All right, starting here. So again, remember, you're starting at the origin. So starting at the origin and following the pattern, what did we have? A sign. Did anyone say a negative sign? Yes. Okay, so we have a negative sign because instead of starting off as a maximum, we started off as a minimum. Okay, now we're going to go through the steps. Our A. How far are we from our axis of our wave? 3. And it has to be a what? -3 because our sign is negative. All right, next we're going to find our period. Your period equals what? 4, because we start at 0 and end at 4. our b equals 2 pi divided by 4, which is just pi over 2. So then you should have had not negative 3, positive 3, 4, and then you had negative 3 sine of pi over 2x. 5 times 2. Doable? Okay. All right. Try again. Last one, and then we are moving on to talk about how absolute value affects our functions.
Wait, it was negative 3 sine 4x. 2 pi over 2 over.
It's your
pi.
b. So what's our b
Yeah.
value? All right, your turn.
Pi over 2x. Sorry.
Your hint for this one is you cannot see the whole thing. So use what you can to figure out your period. Does that make sense? You can't see the whole thing, but use what you can to figure out your period. And we'll see how you do. Here we go. Let's see how we did. So looking at this graph, what did you guys say we had?
Cosine.
It is. It's negative cosine. It should have been a negative cosine, because if you follow it, what is your cup going to be doing? It's going to be emptying, right? It's going to be going down, huh?
Could you technically be sine if you had a
If we were talking about it not from being at the origin, yes, it would have a horizontal translate. But-
That's exactly what
Yes. Which is what 9.5 is talking about, how every graph actually is a sine and a cosine. And we're going to talk about writing both. So that's what 9.5 is. All right, here we go. But your A. So your A coming down from our max to our axis of symmetry, our axis of our wave is 4. So we know A equals negative 4, and our amp is positive 4.
Oh, okay.
Okay, your period. So remember, I was giving you the hint that you can use what you see for your period, right? So I can see a complete cycle right here. I can see a full cycle right here, right? And how long is that period?
4 pi.
4 pi. So we know that our period is 4 pi, which helps us solve for our b. So 2 pi divided by 4 pi equals 1/2. So my equation is
Negative 4 cosine 1/2x.
perfect. Bam. How do we feel about simple graphs? Good. All right. The last part about simple graphs is just how are graphs affected by absolute value? Again, you see nothing. I should have did a sine example instead of a cosine example, which is, maybe I'll change that. We'll see. All right. So we're gonna first talk about here. We have f of x equals 3 cosine x, right? So looking at this, we know that our amp equals 3. Amp equals 3. And because there's no change to our x, our period is 2 pi. Okay, so we know that part, right? So when we're graphing this, we have everything we need to graph. But we're only going to graph the right side first. So if I'm at cosine with an amp of 3, that means instead of being at 1, I'm going to be at 3. I'm still going to cross. But when I get here, what would happen?
It would go back up.
It would bounce.
Have a negative.
There we go. It would bounce back up. So once I got to pi, I'm like, oh, I'm going down to negative 3. He's like, ha, 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 ha. No, you're not. Psych. And the reason being is absolute value. So when your absolute value is around the entire right side, that means there are no negative y values. All negative values become positive. So the same thing would happen.
So the period is smaller, or
It doesn't affect your period. Okay, and then on the left-hand side, because cosine is an even function, it's just gonna do what? Mimic itself, right? So it's still gonna be. And notice, do I have any negative y values? Nope. My domain is all real numbers, and my range is
From 0 to
from 0 to 3. So this happens only when it's the entire right side of the function, right? That is being absolute value is being applied. Yes. Oh, okay. Yes. All right. So here you have f of x of 3 cosine of absolute value of x. So again, everything is pretty much the same. The amp is still what? 3. Your period is still 2 pi. Okay. The difference here is that we're going like this. We're going like this. And here is our right side. Now, because I'm taking the absolute value of x, what this is saying is that whatever f of x equals, f of negative x is going to be the exact same thing. Well, isn't this the rule for even functions anyway? Yeah, this is the even function rule. So is that going to make it look any different for our graph? No. Now, what we're going to draw on top of this is sine and see how it affects the sine graph. That got weird, but you. All right. So now we're going to do g of x. So g of x is going to equal 3 sine absolute value of x. So the amp is still going to be the same. We're going to be at 0. Our max is at 3. Our min is at -3. And then we come back up. Pretend that I went through that. Okay, so talk about sine. What kind of function is sine?
Oh,
It's odd. When you're taking the absolute value of x, it's going to turn an odd function into an even function. So instead of it doing the opposite behavior, it's going to mimic on the other side. So it reflects exactly. Look at you. Look at you. Good job. So if the original function is already even, will taking the absolute value of x have any effect on it? No. But if the original function is odd, what is it going to do? Turn it into an even. And that concludes 9.4. Was it terrible?